Welcome to the Walton Pi. Today we're going to be going through some different problems and topics and stuff that would show up on a common midterm for Calculus 1. So the topics that we're going to cover are limits at infinity, derivatives and rates of change, how we can think of derivatives as a function, how to find the derivatives of polynomials, of exponential functions, of trig functions. We're going to talk about the product rule, the quotient rule, the chain rule, and then talk about common types of problems that test these sorts of things that would be problems that you might expect to see showing up on a midterm. So to get started, let's start with limits at infinity and infinite limits. So let's calculate what is the limit as x goes to infinity of 5x squared minus 13x plus 2 over 7x cubed minus 4x plus 3. So if we're trying to evaluate this limit, we are going to need to figure out how to approach this. So take a minute and try and figure out how might you approach this, and then unpause the video when you're ready. So the way that we should probably approach this, or one way that we could approach this, this is not the only way that we could do this, is we could multiply the top and bottom by the same thing in order to get something that is a little bit easier to work with. So if we were to multiply the top and the bottom by 1 over x squared, and the bottom by 1 over x squared as well, what we are going to get is this is equal to the limit as x goes to infinity of 5 minus 13 over x plus 2 over x squared all over, we have, let's see, 7x minus 4 over x plus 3 over x squared. And now we can look at this as the limit as x is going to infinity. So this top, this is going to a 5, and this bottom, this is going to infinity. So 5 over infinity, this is going to go to 0. So we could have done it this way, but we could have also done this by multiplying the top and bottom by 1 over x cubed. That would have given us a different one that we could have also done. So let's go through the process of how we would do that if we had multiplied the top and bottom by 1 over x cubed. So if we were to do this instead, this would have become the limit as x goes to infinity of 5 over x minus 13 over x squared plus 2 over x cubed all over 7 minus 4 over x squared plus 3 over x cubed. And then this one, when we evaluate this, the top of this limit, this is going to 0 over 7, which is also going to 0. So whichever way you think of it, both of those are going to be ways that you can approach this. So now, let's do another one, and this time, if you weren't able to figure out that first one on your own, pause the video after I write down this limit and try and figure it out on your own. So what is the limit as x goes to negative infinity of 4 minus x times x squared plus 3 divided by 2x cubed plus 2x minus 7. Go ahead, pause the video, and try and figure out what this limit would be. So to figure this out, a good first step might be to expand out the top of this fraction. So this would become the limit as x goes to negative infinity of, let's see, we have a 4x squared plus 12 minus x cubed minus 3x all over 2x cubed plus 2x minus 7. And now because this has an x cubed on the top and the bottom, this means that multiplying the top and bottom by 1 over x cubed is probably our best route. And in doing so, this is going to turn this into the limit as x goes to negative infinity of, we have 4 over x plus 12 over x cubed minus 1 minus 3 over x squared all over 2 plus 2 over x squared minus 7 over x cubed. And so this is going to be, let's see, everything on the top goes to 0 except the minus 1. and everything on the bottom goes to 0 except the 2, so we get a negative 1/2. Let's finish up talking about limits with infinity involved and do one last problem. So let's look at the limit as x approaches 2 of 5x minus 7 all over x squared minus 4x plus 4. We are trying to figure out what is this limit. Go ahead, pause the video, and try and figure this one out on your own. Alright, so the first thing we might try and do is to just plug in 2, and on the top we're going to get 3, and on the bottom we get 0. Well, 3 over 0, that, normally we would say that does not exist, but this might be going to infinity or negative infinity. The question is it always going to the same one? Because it might be going up like this, or it might be going down like this, and both of these cases we could say that the top one goes to positive infinity, the bottom one goes to negative infinity, but if it's doing something like this, then we would have to say that the limit does not exist. So the question is, which of these cases is it? Well, what we can do is we can rewrite this as the limit as x goes to 2 of 5x minus 7 over x minus 2 squared. So what we can do is we can think of what's happening as x is getting really close to 2. Well, when x is close to 2, this is getting close to positive 3. Because we're getting close to 2, so it's about 10 minus 7. So it's close to a positive 3. And as x gets close to 2 on the bottom, this is getting close to 0. But the important thing to notice is it's x minus 2 squared. So that means no matter what number we're putting in, it's always going to be positive. So this is getting close to a positive 0. So we're really dealing with a 3 over like a positive 0. So this is going to a positive infinity. And it's going to do that from both sides. And so that's one way that you can think about this. So these are the sorts of limits that you might see. Another slightly more extreme problem that we might come across might be, what is the limit as x goes to infinity of e to the x sine of x plus 4? So e to the x times sine of x and then plus 4 at the end. What is this going to be? Well, this is going to actually be a squeeze theorem problem. The squeeze theorem does not only apply when we are close to 0. So go ahead and try and figure out how we might approach this using the squeeze theorem. Okay, hopefully that was enough time for you to figure it out. If it wasn't, pause the video. You have that ability. So what we need is we need a function that's always bigger than e to the x sine x and a function that's always smaller than e to the x sine x plus 4. So what we can do is we can squeeze e to the x sine x plus 4. This is always going to be less than or equal to just e to the x plus 4. Because sine x is always between negative 1 and 1. So that means that we can be able to squeeze e to the x times sine of x underneath e to the x times 1. And we can always stick it above negative e to the x plus 4. And so these are going to be our two functions on either side. And as x goes to infinity, well, this one is going to negative infinity plus 4, so this one's going to negative infinity, and this one is going to positive infinity. Well, that means that this one's not working. But what we could do is we could change the limit just a little bit, so it becomes the limit as x goes to negative infinity. Well, e to the negative infinity, that's close to 0. So instead of going to infinity, this is going to 0, and this other one is also going to go to 0 plus 4. So that means that both of these are going to 4 if it is negative infinity. Now, if it was positive infinity, this would be swinging wildly back and forth between positive and negative infinity over and over and over, and it's not converging to anything. So as it was originally, with the limit as x goes to positive infinity, that limit would not exist. Okay, so let's now switch topics a little bit. We're still going to be doing limits, but let's now talk about how we can do derivatives and rates of change. So let's go through a few different functions and try and find the derivatives using the definition of the derivative. So for all of these, we are going to be using the definition of the derivative. So we can't use the product rule, the quotient rule, the power rule, none of those rules. We are only using the definition of the derivative. So only using this, let's find the following. So if we have f of x is equal to 4x cubed minus 7x plus 3, find f prime at 3. If g of x is equal to the square root of 2x minus 4 plus 5, find g prime at 2. Actually, no, that's a bad one. Let's not find g prime of 2. Let's find g prime of 3. And then if h of x is equal to 14x squared plus 7x plus 3, let's find h prime of negative 2. So go ahead, pause the video, and try and figure out what all three of these values are going to be. Okay, hopefully that was enough time. Let's go through and figure out what are these different ones. So let's start by doing f of x. So let's move these down so that we have enough room. Oh, come on, why didn't they move? All right, so moving these to the side for the moment. Okay, so to figure out the derivative, so we need f prime of 3. There's a couple different ones that we could do. So one is we could look at the limit as x approaches a, so in this case as x approaches 3, of f of x minus f of 3 all over x minus 3. So that's one way that we could do it. The other one is we could do the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. Both of these are valid definitions of the derivative at a point. So we could use either one to go about it. So let's start by doing this one. And then I will do this method for the g of x problem. So using our first definition, we are going to get, this is the limit as x approaches 3 of f of x, so 4x cubed minus 7x plus 3 minus f of 3. So that is going to be 4 times 3 cubed. 3 cubed is 27, so let's say 4 times 27 minus 7 times 3 plus 3 all over x minus 3. So this is now what we're going to be going through and doing. So we get the limit as x goes to 3 of 4x cubed minus 7x plus, let's see, we have 3 minus 4 times 27, that is 108, minus 21 plus 3, all over x minus 3. That becomes the limit as x goes to 3. Let's see, 108 minus 21, that is 87. So 87 plus 3, that's 90. So 3 minus 90, that's a negative 87. So the top is 4x cubed minus x minus 87 all over x minus 3. This is going to be a bit tricky because we have to somehow factor x minus 3 out of the top. So we hope that we'll be able to get, this is the limit as x goes to 3 of x minus 3 times something all over x minus 3. Well, let's pretend that we know it's going to work, and it should. So let's hope that it is going to end up working out. So if we were to do that, we need x times something to give us this 4x cubed. So let's say that we have x minus 3 times ax squared plus bx plus c. And we need to solve for what a, b, and c need to be. So if we were to expand out x minus 3 times ax squared plus bx plus c, what we would get is we have ax squared times x gives us an ax cubed, then we have plus bx squared, and then a plus cx, and then we have a minus 3ax squared minus 3bx, and then minus a 3c. So ax cubed has to be the 4x cubed. So that means we know that a has to be 4. In order for this to even be possible, that has to be a 4. So now we know a couple of these things. So we know that we have a 4 and a 3 times 4 here, so 3 times 4 gives us 12. Okay, so that's one of the ones that's easy to figure out. Let's figure out the c. Okay, well, let's see, negative 87 has to be the negative 3c. So 87 divided by 3, well, that's going to be 29. So that means that we know that c has to be 29. Okay, so we got that part. Now we just have to figure out what's b. Well, we now have enough information to figure it out. We know that b minus 12, that's this part right here, has to be the coefficient of x squared. Well, x squared is 0. We don't have an x squared term in our original thing, so that means that b has to be 12. So it's going to be 4x squared plus 12x plus 29. Okay? Do you follow this? Does this make sense? I really hope so. I hope this is making sense to you all. Okay, so let's just check that this is actually going to work out as well. So if b is 12, then that means that this one is going to have to agree with the minus 7x. So c, that's 29. So 29 minus 3 times 12, so that's 29 minus 6, that is negative 7, which works out. So we have successfully factored this. So what we can do now is, now that we have that, now that we've successfully figured out how to factor the bottom, or not the bottom, how to factor the top, we now have the ability where we can cancel out this x minus 3 piece, and we are now left with the limit as x goes to 3 of 4x squared plus 12x plus 29. Well, now we can plug in 3, so that's equal to 4 times 3 squared is 9, plus 12 times 3 plus 29. So this is equal to 36. 6 plus 29, that's 72 plus 29, that is 101. So that tells us that f prime of 3 is 101. I hope that one made sense at least. If it didn't, let's go through and check the others. Now, what we could do is we could also check to see, does this agree with what would happen if we were to plug in the derivative and then plug in 3. So taking the derivative of that using just the power rules, that would give us 12x squared minus 7. If we then plug in 3, that becomes 12 times 9 minus 7, which is 108 minus 7, which is 101. So this work that we did here, that is not allowed if we are asked to do it using the definition of the derivative. However, we can do this to check our work. So that is why that is something that's helpful to be able to check your work with this, now that we know all of those different rules. So let's do this again, but this time with g of x. So let's move h of x out of the way this time. Okay, so this time for the g of x, we are going to want to use the second definition. So the limit as h goes to 0 of g of, let's see, we are trying to find it at 3, so it'll be g of 3 plus h minus g of 3 all over h. So go ahead, pause the video, and try this on your own if you haven't already. Okay, so what we're going to do is now we're going to just plug these in to see what we get. So this will become the limit as h goes to 0 of g of 3 plus h. So that's the square root of plugging 3 plus h in everywhere. So 2 times 3 plus h gives us a 6 plus 2h minus 4. plus 5 minus the square root of this one we just plug in 3. So that becomes the square root of, let's see, 2 times 3 is 6 minus 4, so that's the square root of 2 plus 5 all over h. So that becomes the limit as h goes to 0 of the square root of 2 minus 2h plus 5 minus the square root of 2 minus 5. Well, those 5s can just cancel straight away. So we are left with just the limit as h goes to 0 of the square root of 2 minus 2h minus the square root of 2 all over h. So how are we supposed to take that limit? Like, there's not an h that's easy to cancel. Well, the answer is going to be multiplying the top and bottom by the conjugate of the top. So that's going to be multiplying the top and bottom by 2 minus 2h plus the square root of 2. So that is what we multiply the top and bottom by. And this will turn into the limit as h goes to 0 of 2 minus 2h minus 2 all over h times the square root of 2 minus 2h plus the square root of 2. Well, 2 minus 2h minus 2, this 2 and this 2 can cancel. Then we have only an h on the top and bottom, so then we can cancel the h's, and so we are left with the limit as h goes to 0, negative 2 over the square root of 2 minus 2h plus the square root of 2. And now when h is 0, we can plug this in, so we get negative 2 over the square root of 2 plus the square root of 2. So this is going to be a negative 1 over the square root of 2, or negative root 2 over 2. Either of these would be acceptable answers. I hope that one made sense as well. If it didn't, try it on your own and see if you can figure out all of the different steps. Alright, so our last one that we were trying to figure out, so that's going to be what g prime of 3 is. It's just going to be negative 1 over the square root of 2. Okay, so now let's figure out h of x. So let's move these over so we have enough room. Okay. So this one, we are completely free to use either method. Because this is still at a point, we can just evaluate this using either definition. So let's do the limit as h goes to 0. And the reason I'm going to default to this one most of the time is because this is the one that's closer to the definition when we are taking the derivative of a function. So that is going to be the limit as h goes to 0 of h of negative 2 plus h minus h of negative 2 all over h. So this becomes the limit as h goes to 0 of 14 times h minus 2 squared plus 7 times h minus 2 plus 3 minus 14 times negative 2 squared minus 7 times negative 2 minus 3 all over h. Well, the plus 3 and the minus 3, those can cancel straight away. And we are left with the limit as h goes to 0 of 14 times h minus 2 squared. That becomes h squared minus 4h plus 4 plus 7h minus 14. And then minus, let's see, what is this? 14 times 4. Let's see, 14 times 4, that's 40 plus 16. So that's minus 56. So we have a minus 56 and then a minus 7 times negative 2, so that's a plus 14. Okay, this time that 14 and that 14 can cancel. And that is all over h. Let's see, so that's the limit as h goes to 0. If we multiply out the top, that becomes a 14h squared minus 4h times 14, so that's a minus 56h. Then we have a plus 56 plus 7h minus 56 all over h. Have 56's cancel, and so we are left with the limit as h goes to 0 of 14h squared minus 56h plus 7h all over h. Well, we can cancel an h from everything now. And then we can plug in h equals 0. And we get 0 minus 56 plus 7. Negative 56 plus 7, that's going to be negative 49. So that means that h prime of negative 2 is negative 49. And that would be how we would be able to take these different derivatives. Let's now do some derivatives using just the definition of the derivative. So let's, instead of trying to find h prime of negative 2, let's try and find what is h prime of x. So if we just move this function down, we have that here. Let's move it down a little bit more. Okay. So if we have this and we are trying to find what is h prime of x using the definition of the derivative, what we are going to have to do is go through and do the limit as h goes to 0. Oh, I just realized that last one might have been a bit confusing because h was both the function and what we were sending things going to 0 to. So I apologize. Let's fix that by changing our function to h. So f of x and f prime of x. So it's the limit as h goes to 0 of f of x plus h minus f of x all over h. So this will be the limit as h goes to 0 of f of x plus h. That is a 14 times, whoa, what on earth just happened? Okay, so that will be the limit of, let's see, we got 14 times x plus h squared plus 7 times x plus h plus 3 minus, and then we to subtract from this just f of x. So minus 14x squared plus 7x plus 3 all over h. So this will be the limit as h goes to 0 of, expanding the top, we get a 14 times x squared plus 2xh plus h squared plus 7x plus 7h plus 3 minus 14x squared minus 7x minus 3 all over h. And then if we expand out the top again, so we multiply the 14 out all the way through, we get the limit as h goes to 0 of 14x squared plus 28xh plus 14h squared plus 7x plus 7h plus 3 minus 14x squared minus 7x minus 3 all over h. Let's look for things that will cancel. Well, we have a plus 3 and a minus 3. Those will cancel. We have a plus 7x and a minus 7x, and a plus 14x squared and a minus 14x squared. So that means that the only things that did not disappear are going to be the limit as h goes, so it'll be the limit as h goes to 0 of 28xh plus 14h squared plus 7h all over h. Well, we can cancel an h out from everything, and we are left with, when we plug in h equals 0, we get 28x plus 0 plus 7. So that means that this is going to be equal to f prime of x. That is the derivative of f. Let's do one more example of this. So let's say that we have, as our function, we have g of x is equal to the square root of 4x plus 3 minus 7, and you are asked to find g prime of x using the definition of the derivative. So you can't use the chain rule, you can't use any of those other rules, you have to use the definition of the derivative. Go ahead and try this for a moment using the limit definition of the derivative. Go ahead and unpause the video when you are ready. Okay, so the first thing we need to do is this will be the limit as h goes of g of x plus h minus g of x all over h. So this becomes the limit as h goes to 0 of the square root of 4 times x plus h plus 3 minus 7 minus the square root of 4x plus 3 minus 7 all over h. So this becomes the limit as h goes to 0 of the square root of 4x plus 3 plus 4h minus the square root of 4x plus 3, because this minus 7 and this minus 7 end up canceling each other out. And then it is all over h. And at this point, we need to figure out how can we cancel an h out from the top. We can't just go boom, boom, we're done. That's not a valid thing that we can do. So what we have to do is we are going to multiply the top and bottom by the conjugate. So that is going to be multiplying the top and bottom by 4x plus 3 plus 4h plus the square root of 4x plus 3. So we are multiplying the top and bottom by that. And when we do this, this is going to have the nice property of the top becoming something that's a lot nicer to deal with. So this becomes the limit as h goes to 0 of 4x plus 3 plus 4h minus 4x plus 3 all over h times the square root of 4x plus 3 plus 4h plus the square root of 4x plus 3. Well, if we distribute out the top, it turns out that this 4x plus 3 cancels with this 4x plus 3, and all we're left with is 4h on the top, which can then have that h and this h cancel. So this is now just the limit as h goes to 0 of 4 divided by the square root of 4x plus 3 plus 4h plus the square root of 4x plus 3. And now we can plug in h equals 0. So that will be 4 over the square root of 4x plus 3 plus the square root of 4x plus 3. So this is going to be 4 over 2 times the square root of 4x plus 3, or just 2 over the square root of 4x plus 3. Now, we might ask, is this actually going to be the derivative? And like, did I mess up anywhere? That would be a nice thing to be able to check on the test. So what you could do is have, like, right at the end, like, checking work, and then have, like, not solving, so that they know that you're not trying to do it this way. But what we can do is we can then say, because our original function was g of x is equal to the square root of 4x plus 3 minus 7, we could find g prime of x using the chain rule. So we have a square root, so that's going to be a 1 over 2 times the square root of that inside, so 4x plus 3, multiplied by the derivative of the inside, which is just a 4. Oh, that's what we had right there. Great. We know we were able to do this successfully. If you don't know that square root rule, rewrite this as 4x plus 3 to the 1/2 minus 7. And then you can bring the 1/2 down, and it becomes a 4x plus 3 to the negative 1/2 as the power, and then multiply by 4 at the end. But the chain rule does verify that this is going to be the derivative. So that's something nice that we can be able to do to be able to check that. Alright, so let's now practice doing some problems using the power rule. So, using the power rule, compute the derivatives of the following. Let's see, let's write it like this. So of f of x equals, and then we're going to just list a bunch of functions and then pause the video, write down all of the derivatives, and then we'll see if you were able to get them, because hopefully these should be fairly straightforward. So let's say we got x squared is 1, we got x to the 90, x to the 2021, we got x to the 3/4, we have 1 over x squared, we have the square root of x, we have the cube root of x, we have x to the 17 minus 1 over x, and then we have x squared plus 4x divided by x cubed. So, use the power rule to compute all 9 of these derivatives. Go ahead and pause the video if you need the time, and unpause it when you are ready. Okay, so the rule for the power rule is that we first are just going to bring down the power to the front. So it says that we have, if it's x to the n, yeah, that's a bad format, let's write it a little nicer. So x to the n, when we take the derivative, is going to become n x to the n minus 1. So x squared will become 2x to the 1, x to the 90 becomes 90, x to the 89, x to the 2021, that becomes 2021, x to the 2020. And it's going to work the same thing on these fraction ones. So x to the 3/4, that's going to go to 3/4 x to the 3/4 minus 1, which is a negative 1/4. 1 over x squared, well, that's the same thing as x to the minus 2. So then that is going to go to a negative x to the minus 3, or another way to write that is negative 2 over x cubed. The square root of x, that's the same thing as x to the 1/2. So that means that is going to go to a 1/2 x to the negative 1/2, or a 1 over 2 square root x. That's another way to write that. The cube root of x, that's the same thing as x to the 1/3. So that is going to go to a 1/3 x to the negative 2/3. X to the 17 minus 1 over x, well, that's just adding two different power rule problems. So this one goes to a 17 x to the 16. 1 over x, that's the same as x to the minus 1. So that becomes a minus negative 1x to the minus 2, or 17x to the 16 plus 1 over x squared. And then the last one, x squared plus 4x over x cubed. We could do this with the quotient rule, but we could also break this up and use the power rule. So this is the same thing as x squared over x cubed plus 4x over x cubed, which is 1 over x plus 4 over x squared, or x to the minus 1 plus 4x to the minus 2, which means that this, under the power rule, is going to just go to a negative 1x to the minus 2 minus 4 times 2 times x to the minus 3, so a negative 1 over x squared minus 8 over x cubed. And that's what that derivative would be. So along with the power rule, another rule that's not too difficult to remember is the rule for taking derivatives of e to the x. So if f of x is equal to something like, say, 7x plus 4 e to the x, then the derivative of this is going to just be, well, 7x, that's going to just be 7, but then the 4e to the x, the rule with e to the x is it just sticks around. So this is just going to be still a 4e to the x. The derivative of e to the x is e to the x. That's the nice thing about it. Okay, so that is, that's the power rule and the rule for exponential functions. Let's now just do some other functions. So let's jump into the trig functions. So let's compute the following. So compute the derivative of f if f of x is equal to, we got sine x, we got cosine x, we got tangent x, we got secant x, we got cotangent x, and then we got cosecant x. So go ahead and compute all 6 of these derivatives. Go ahead and pause the video if you need, but we are going to go through all of these together in a moment. Okay, so the rule for some of these, sine of x and cosine of x, these are ones that you just need to memorize. So sine of x, that goes to just cosine of x. And the derivative of cosine of x, that just goes to negative sine of x. Okay, so those two are just two that you have to memorize. Derivative of sine is cosine, derivative of cosine is negative sine. Okay, so now what we're going to do is we are now going to figure out what is tangent of x. What's the derivative of tangent? Well, tangent can be written as sine x over cosine of x, which means that the derivative can be computed using the quotient rule. So this is going to be, we got low d high, so that's going to be a cosine x times derivative of the top, that's another cosine x, minus the top, so sine x, times the derivative of the bottom, so that's a negative sine x, so that becomes a plus sine x squared, all over the bottom squared, so that's a cosine squared x. Cosine x squared plus sine x squared, that's just a 1. So this is 1 over cosine squared x, which is secant squared. So the derivative of tangent is secant squared. Speaking of secant, what is the derivative of secant? Well, first let's write secant in terms of sines and cosines. So secant is 1 over cosine of x. So now, using the quotient rule, we are going to have the following. So we have low d high, so that's going to be a cosine x times 0, minus high d low, so the derivative of the bottom is, so bottom is cosine, derivative of that is a negative sine, so it becomes a plus sine x, all over the bottom squared, so that becomes a cosine squared x. So that is sine x over cosine squared x, which is the same thing as sine x over cosine x, times 1 over cosine x, which is tangent x secant x. So that is the derivative of secant of x. Okay, so now let's do cotangent x. Okay, start by writing cotangent in terms of sines and cosines. Cotangent is cosine of x divided by sine x. And then we're just going to chug through the quotient rule. So we got low d high, so that's going to be sine x times the derivative of the top, that's a negative sine x, so we have a negative sine x squared, minus high d low, derivative of the bottom is another cosine, so that's a minus cosine x squared, all over the bottom squared, so that's a sine x squared. Well, the top just becomes a negative 1, so we have negative 1 over sine squared x, and 1 over sine is cosecant, so this is negative cosecant squared x. That is going to be the derivative of cotangent. And for the last one, make a wild guess as to how we're going to do it. Well, I hope you guessed right, because we're going to do the quotient rule again. So, cosecant x, that is 1 over sine x. So, taking the derivative, quotient rule, here we go. We got low d high, so that's sine x, times derivative of the top, 0, minus high, so minus 1, times the derivative of the bottom. Well, the derivative of the bottom is cosine x, so we just have a minus cosine x, all over the denominator squared, so that's a sine squared x. So this is negative cosine of x divided by sine x times sine x, so times a 1 over sine x there. Well, cosine over sine, that's cotangent. So we have a negative cotangent x, and then 1 over sine, that's cosecant. So negative cotangent x cosecant x is the derivative of cosecant of x. Okay, so we briefly touched on the quotient rule, so let's go into some of these different rules of integration techniques, because these are the main ones that we have and that are going to be showing up on this upcoming test. So let's go through and practice some of the different types of rules that we can do. So let's do, come on, clear the canvas. Okay, so using the power rule, not the power rule, the product rule. So using the product rule, compute the following derivatives. So we got f of x is equal to x squared cosine of x. We got g of x is equal to 4x cubed e to the. We got h of x is equal to 7x e to the x cosine of x. And we got j of x is equal to x cubed plus 7x squared minus 2 times sine of x minus 4x minus e to the 2x. So we are going to compute all four of these derivatives using the product rule. So go ahead, pause the video, and tackle each one on your own, and then unpause it when you're done, and we will go through it together. So let's start at the top. That's a very good place to start. So we got f prime of x is, now the product rule, let's write that down real quick. Let's just remind ourselves what the product rule is. So let's give ourselves just a little bit more space. Okay. So if we have a function f of x times g of x, then the derivative of this is going to be f prime of x times g of x plus, plus f of x times g prime of x. This is the product rule. So using this, let's go through each of these different derivatives. So let's get this nice and centered. So f prime of x. Well, following this rule, we are going to break this up into the product of a couple functions. So we got x squared times cosine of x. So first, we are going to take the derivative of x squared. Well, that's 2x, and then we are going to multiply it by cosine x. So cosine x just sticks around, and then add to that f of x, or our first function, x squared, times the derivative of the second function. Now, the derivative of cosine, that is negative sine x. So that means our derivative is going to be a 2x cosine x minus x squared sine x. And that is where we would stop and write down our answer. So if you weren't able to get that, go ahead, pause the video, and try and get g of x. If you were, let's go through and see if we were able to figure out g of x. So again, we are going to have the derivative of the first, so the derivative of 4x cubed. So 4x cubed, the derivative of that is a 12x squared times e to the x plus first function, 4x cubed, times the derivative of e to the x. This is an e to the x. So this one is just going to be 12x squared e to the x plus 4x cubed e to the x. And that is the answer that we would write down on our test. Okay. The next one's a little bit trickier. So we need to figure out what is h prime of x. Well, we have to split this up into two pieces. So we kind of have to decide how do we want to split this. So maybe we'll have this as one function, and then we'll have cosine of x as our second function. So this is going to be the derivative of our first function times our second function, so times cosine x, plus our first function, 7x e to the x, times the derivative of our second function. Derivative of cosine is a negative sine x. Now you notice I skipped the derivative of the first function. Well, that's because the first function, we're going to have to do a product rule for that one too. So if we break this first function up into 7x times e to the x, then we can be able to take that derivative. So now only looking at 7x e to the x, we have the derivative of the first, so that's going to be a 7 times our second function, e to the x, plus our first function, 7x, times the derivative of the second function. So the derivative of e to the x, let's just e to the x again. So that means that our function, so let's give ourselves just a little bit more space again. So that means that our h prime of x is going to be 7e to the x cosine x plus 7x e to the x cosine x minus 7x e to the x sine x. That is going to be the derivative of h of x. Now, that one is a little bit trickier. If you were having a hard time with that one, try and write down a few different functions all multiplied together and have more than two functions together, and then practice taking the derivative several times to see, are you able to figure these sorts of things out. There's a useful website called Symbolab, Symbolab. So Symbolab is a useful place to be able to check your derivatives, but do not use Symbolab to compute derivatives because you need the practice, and it is much better to practice and mess up somewhere than to just get the right answer. Because if you think about it, you're paying for your education, you're paying to be able to learn, and by just bypassing those things, you're paying to not learn anything. So you're paying to be able to learn how to use a computer, which is not something that is worth your tuition. So use Symbolab as a way to check your answer when you're trying to figure out, am I doing this properly? But do not use it to be able to just go through and compute derivatives for your homeworks or for the test. So that is something that we would need to do. Okay, so now let's go on to our last function. So let's figure out, how can we take the derivative of this? Well, the first one, we have two functions multiplied together, so that makes it a little bit easier for us to just figure out what's the derivative. So it's going to be the derivative of the first. So x cubed goes to a 3x squared, 7x squared goes to a plus 14x, and then minus 2 goes to a plus 0, so let's not bother writing that down. So it's derivative of the first times the second, so times sine x minus 4e to the x, plus the first, so we don't change that one, so x cubed plus 7x squared minus 2, times the derivative of the second. Okay, so the derivative of sine, well, that's just cosine of x, minus 4e to the x, derivative of that is a minus 4e to the x. So that's the derivative of this piece. How should we attack e to the 2x? Well, we could use the chain rule. So that's one way we could do it, and we would get a minus 2e to the 2x. Or what we could do is we could go through and write this as a product rule. Because we could rewrite e to the 2x, we could rewrite that as e to the x times e to the x. And so once we have it written this way, then that is pretty clear how we can do that as a product rule. So that is going to be a minus, we got derivative of the first, well, that's e to the x times e to the x, plus the first, e to the x, times the derivative of the second, that's another e to the x. And so all in all, we are going to get exactly what we had here, minus 2 e to the 2x's. So it didn't matter if we used the product rule or the quotient rule. No, not the quotient rule. The product rule or the chain rule. Both of them ended up giving us the same. And so that's just another reason as to why we have all these different rules, and a suggestion that it's not always going to be the first one that you see that's the best way. In this case, it might have been if you recognized the chain rule, but it doesn't matter which technique you use, because any way that you can go about doing it, as long as you're doing all of your algebra correctly, you are always going to end up at the same correct answer. So that means in this case, we would write down j prime of x is equal to this really long thing that we just needed to do the product rule twice on. Okay, so now that we've done some product rule ones, let's move on to the quotient rule. So if we are trying to compute the following derivatives, let's clear the canvas. So compute the derivatives of, let's see, we got f of x equals x squared e to the x divided by x cubed plus 7x. We got g of x is equal to cosine of x divided by 1 minus sine squared of x. We got h of x equals e to the x times x squared minus 4 tangent x. divided by 2x minus 7 sine x. And then let's add one more function and have it be k of x is equal to 7 divided by x squared plus sine x e to the x. So compute all 4 of these derivatives. Go ahead, pause the video. These will take some time. So pause the video and unpause it when you are ready to be able to go through these answers together. Okay, so as a refresher, the quotient rule says that if we have f of x over g of x, so if we were to have a function that looks like this, the derivative is going to be low d high, so we got g of x times f prime of x minus high d low, so minus f of x g prime of x all over the bottom squared. So if you write this as high over low, it'll go to low d high minus high d low, square the bottom and off you go. Or a little tune that I've used several times goes low d high minus high d low over low low. Like, that's another one to help you remember it. So just find a way to remember the quotient rule, and then from there you can just go and use it to your heart's content, and probably a little bit past that as well. But if we were to try and compute the following derivatives, let's compute the first one. So f prime of x is going to be, we got low d high, so low is just going to stick around, so x cubed plus 7x times the derivative of the top. Okay, what's the derivative of the top? Well, that's something that we're going to have to take the product rule to be able to find. Come on, let's slide this out of the way. Okay, so we're going to need the product rule. So we got first times the derivative of the second, so that's an x squared e to the x, plus the derivative of the first, 2x times the second e to the x. So that is our low d high. Now we have minus high d low. So we're going to have to subtract the top times the derivative of the bottom. So that's going to be minus x squared e to the x times the derivative of the bottom. That is a 3x squared plus 7. So there's the entire top, and we put all of this over the bottom squared. So all over x cubed plus 7x squared. And that is as far as we are going to simplify it. And that's as far as you would be expected to do it on your test as well. That is a good spot to stop for finding the derivative. Okay, so let's now do g of x. Well, to find g prime of x, we can just go through and do this using the quotient rule again. So we got low d high, so that's a 1 minus sine squared x, times the derivative of the top, negative sine x, minus the top, cosine of x, times the derivative of the bottom. Okay, well, the derivative of the bottom is going to be a chain rule problem, because we need to take the derivative of sine squared of x. And the chain rule is going to tell us that that is going to be a negative 2 sine x times cosine of x. Don't worry, we'll be doing some chain rule problems right after this, so you will be able to get some practice with that. And then this is all over the denominator squared, 1 minus sine squared x squared. And that is what the derivative is. However, if we were to simplify this first, we would be able to take the derivative a lot easier. So, if we were to rewrite this again, but first simplify it. So we also have that g of x, so that's going to be a cosine x over 1 minus sine squared x. Well, 1 minus sine squared x, that's actually just cosine squared x. So this is just cosine x divided by cosine squared x, which is just a 1 over cosine x, which is actually just secant x. So that means we could just jump straight to, if we remember the derivative of secant, g prime of x, come on, make it a g. Okay, so g prime of x, the derivative of secant, well, we did that earlier. That is secant x tangent x. So wait, you're telling me that this thing that we have above there is the same thing as secant x tangent x. And it turns out it is. It's not the most straightforward thing to show, but it is actually another way of writing secant x tangent x. You can do it by doing a bunch of trig substitutions and trig identity properties, and you would be able to work it out and be able to get there. It's just something that you wouldn't really expect, but it is going to be something that is true. So sometimes it might be easier to simplify before you try and take a derivative, if it's possible, and in this case it was, so that was why this one was pretty nice. Okay, so let's now do the next one. So let's look at the derivative of h of x. Well, h prime of x, we got to follow the pattern. We got low d high minus high d low all over the bottom squared. So we got low d high, so that's a 2x minus 7 sine x. D high, derivative of the top, this is a product rule. So we got first times the derivative of the second, so that's going to be an e to the x times 2x minus 4 secant squared x. And then we add the derivative of the first, well that's an e to the x times the second, x squared minus 4 tangent x. So this is low d high. We still have minus high d low. So we got still a minus high minus e to the x times x squared minus 4 tangent x. D low, so bottom is 2x minus 7x. So the derivative of the bottom is a 2 minus 7 times sine x. Derivative of sine, that's cosine. So 2 minus 7 cosine x. And then this is all going to be over the denominator squared, so all over 2x minus 7 sine x squared. Yikes. That one's just huge. And we are not going to even try and simplify this. Because it is this big mess. Like sure, like we could probably pull an e to the x out from everything, but like other than that, there's not really much that we can do to simplify. So we're just going to leave it at this because this is as good of an answer as we can get. Okay, so now for our last one, k of x. Well, we got to follow the quotient rule again. So we got low d high. That's going to be x squared plus sine x e to the x times the derivative of the top. Well, derivative of 7 is 0. So we got low d high. That just goes to 0. Wonderful. But then we still have a minus high d low times the derivative of the bottom. Well, derivative of x squared, that's 2x. But then sine x e to the x, that's going to be a product rule. So we got 2x plus first times the derivative of the second, so that's a sine x, times the derivative of e to the x, that's e to the x, plus the derivative of the first times the second, derivative of sine, that is cosine x, times the second, e to the x, all over the denominator squared, x squared plus sine x, e to the x squared. So this one we can simplify a little bit because one of the terms goes to 0. So we just have negative 7 times 2x plus sine x e to the x plus cosine x e to the x all over x squared plus sine x e to the x squared. And that is going to be what k prime of x would be. And that is going to be how we would be able to find all of these different derivatives. Alright, the last rule that we're going to talk about today in this review is going to be the chain rule. So remember that the chain rule says that if we're taking the derivative of f of g of x, so both f and g are different functions, the derivative of this is going to be equal to the derivative of f, where we leave g of x alone, so it's just f prime of g of x, but then we multiply that by g prime of x. And if we have multiple functions nested, we just continue this chain. So for example, if we were taking the derivative of f of g of h of x, this is going to be f prime, where we leave the inside stuff alone, so it'll be f prime of g of h of x, multiplied by g prime of, where we leave the inside of that alone, so that's going to be g prime of h of x. Then last of all, we multiply by the derivative of h. Continue this chain on forever until we reach our very end function, which is usually x, and the reason for that is because the derivative of x is just 1. So that's why we finish off there. So let's use the chain rule to help us find the derivative of the following function. Take the derivative of e to the square root of 5x squared plus. Okay, so we first need to, so go ahead, pause the video, and try and figure this one out. Okay, so let's try and figure this one out. So we first need to figure out what is our outsidemost function. Well, it's e to the stuff. So that means our first derivative is just going to be e to the stuff, because that's the derivative of e to something. So e to the x goes to e to the x. So this is going to be first e to the, and we leave the inside stuff alone. So it'll be e to the square root of 5x squared plus 3x. Okay, so what's our next function? Well, it's the square root of 5x squared plus 3x. So that means the next thing we're going to do is need to take the derivative of the square root. So x to the 1/2, that goes to a 1/2 x to the negative 1/2, or a 1/2 square root x. So this is what's going to go right here. So this is going to be multiplied by a 1/2 times the square root of whatever was on the inside, which in this case was 5x squared plus 3x. And then lastly, we need to multiply by the derivative of this insidemost function, which is a function that we can evaluate its derivative directly. So we are then going to multiply this by the derivative of 5x squared, so that's a 10x, plus 3. And that is going to be the derivative of this function. Let's do another one together. So this time, take the derivative of sine, here, let's put parentheses. So take the derivative of sine of x plus the square root of tangent x minus x cubed. So take the derivative of this function. Go ahead, pause the video, and try and do this on your own. Okay, so what is our outsidemost function? Well, in this case, it's fairly clear. It's sine of all of this inside stuff. The first thing we're going to do is have the derivative of sine, where we leave all of that inside stuff alone. So the derivative of sine, well, that's cosine of that stuff. So this will be cosine of, and the inside stuff stays the same. So it'll be cosine of x plus the square root of tangent x minus x cubed. Okay, the next thing is we have to multiply this by the derivative of that inside stuff. Well, the inside stuff, derivative of x, well, that's easy. That's a 1 plus, but then we have the square root of tangent x minus x cubed. So that means we have a derivative piece that we have to take there. So this is tangent, or the square root of tangent x minus x cubed. So that means we are going to need to do the square root, which we already found. It was 1/2 times the square root of that stuff. So this is going to be a 1/2 square root of that inside stuff, which was tangent x minus x cubed. But we're not done yet. We have to multiply this piece by the derivative of that inside stuff. So just this piece, not the 1 as well, but just this one fraction, the 1/2 square root of stuff, only that piece is multiplied by the derivative of the inside. And this, so we are going to be able to take its derivative, so the derivative of tangent, that is squared x, and then minus x cubed, that goes to a minus 3x squared. And that is all of the pieces, which means that we can close up this parenthesis, and that is the derivative of this function. Okay, let's put all of this together for one massive problem, okay? Like, if you can do this, there is no problem that they can throw at you for the chain rule on the test that you won't be able to do. Like, this is going to be the ultimate function. So let's say that g of x is equal to the square root of, remember, I said this was going to be a monster one, so if you can do this one, you can do any problem. So go ahead and try this one once we finish writing it down. So the square root of 3x squared minus 5x divided by e to the x plus sine x plus 4x squared e to the x squared plus 3 tangent x. I guess I didn't need quite, let's just add a plus 7 at the end. Plus 7 raised to the 5th. Okay. Tackle this problem. Okay? Like, yes, this one's a monster. This one's absolutely huge, absolutely ridiculous. But if you can do this one, you can do any problem that they throw at you with the chain rule. So go ahead, find what is g prime of x. Okay, did you solve it? Okay, if you're just jumping to the solution, pause the video and actually try and solve this one, okay? That'll help you so much more than watching me to go through this, okay? Do your absolute best to do this, and then unpause the video to watch me go through it to see where you're having some trouble so that you can construct new functions on your own to practice with. Okay. Okay, hopefully you've all actually attempted it now, which is the ideal way to study. So let's try and figure out how could we approach this problem. This is just a huge problem. What on earth are we supposed to do here? Well, the first thing is maybe we should rewrite this a little bit to make it a little bit simpler. Because we have the square root of a whole bunch of stuff, then raised to the 5th. So what we could do is we could rewrite this where we take the square root and rewrite it as a fractional power. Because then what this will become, it'll just be all of this raised to the 5/2, which then just becomes a power rule and becomes a little bit easier to deal with. So, what is our outsidemost function? Well, it is stuff raised to the 5/2. So that means this is the first thing that we're going to be doing. So, the first thing, bring down that power. So it'll be a 5/2 times a bunch of stuff raised to the 5/2 minus 1. That's to the 3/2. So that is the first thing, but we have to leave the inside stuff alone. So that's going to just all be 3x squared minus 5x all over e to the x plus sine x plus 4x squared e to the x squared plus 3 tangent x plus 7. Okay, so we got that part. Now we have to multiply by the derivative of that inside piece. Okay, so we're going to be multiplying by the derivative of that stuff. Now, let's just go through piece by piece and figure out what's the derivative of each of these three pieces we're adding together. So first we have the 3x squared minus 5x over e to the x plus sine x. How can we take that derivative? Well, this one's just a quotient rule thing. So we have a quotient rule piece that we have to deal with. So low d high minus high, we're going to need to zoom out a bit, minus high d low all over the bottom squared. So let's just plug in those different pieces. So we got low d high. So low, that is e to the x plus sine x. D high, so that's a 6x minus 5. Minus high, so 3x squared minus 5x times the derivative of the bottom. That goes to an e to the x plus cosine of x all over the bottom squared. So all over e to the x plus sine x squared. Okay, that is the derivative of this piece. So we have now successfully gotten that whole part done. The next one is the 4x squared times e to the x squared plus 3 tangent x. Okay, let's stick that one in. So we have this piece was purple. Let's switch to doing this next one in green. So we got, I'm going to just rewrite the function over here so we can see it when we move over. So 4x squared e to the x squared plus 3 tangent x. Okay, so that is what we are then figuring out here. So we have plus a product rule. Well, let's clump this. So we have 4x squared and then e to all of that stuff. So product rule says we are going to have the derivative of the first, so that becomes an 8x, times the second without any changes, e to the x squared plus 3 tangent x, plus the first, 4x squared, times the derivative of the second. Okay, this is where it's going to get a little bit harder, because this is now going to be a chain rule inside the product rule inside the chain rule. Okay, so how are we going to take this derivative? Well, this is just e to the stuff. So that means its derivative is just e to that stuff times the derivative of that stuff. So times the derivative of x squared plus 3 tangent x, that is times a 2x plus 3 secant squared x. Okay. So what we have now successfully done is we have now successfully finished the derivative of this. Okay, so let's go back and see, is there anything else we have left to do? Okay, so we had that. Okay, need to add the derivative of 7. That's a plus 0. Okay, we have now successfully finished the derivative of the inside, which means we can now close up this parenthesis right here. And so this absolutely huge thing, let's make it so that we can actually see it all. So this huge long thing, that whole piece, that is the derivative of g of x. Was it complicated? Yeah. Was it doable? Yes. We just have to be very consistent and be very careful that we've gone through everything. These chain rule problems are very common ones on a test because they can test all the different things. Because, for example, what we did is we had a power rule right here. We had to use the power rule. We had to use the quotient rule. We had to use the product rule. We had to use the chain rule again. And then inside that, we had some trig functions. We were able to test all of those different things with one question on a test. So is there probably going to be something involving the chain rule in your test? Yeah, it's probably going to be the case. Okay, now let's just talk about some other types of questions that you might see on your test. Alright, so some common questions that you might see on a test might be evaluate the limit as x approaches pi halves of sine x minus 1 all over x minus pi halves. So go ahead, try and figure out how would you evaluate this limit. Okay, hopefully what you did was you recognized that this is in the form, we have the limit as x approaches a of f of x minus f of a all over x minus a. Okay, because what this represents is this is the derivative of f evaluated at a. Well, what's our function here? Well, our function is sine of x. We are evaluating it at pi halves, because sine of x minus sine of pi halves is 1. And so what that means is we have really just this problem saying what is, if f of x equals sine of x, we are asked what is f prime at pi halves. Well, this is just going to be the derivative of sine, which is cosine, evaluated at pi halves, and cosine of pi halves is 0. And so that's how we would be able to evaluate this limit. So let's do another type of problem. Another one that they might give you would be something that would be asking what value of c makes y equals 2x plus 12 tangent to the curve f of x equals c times the square root of x minus 4 plus 2. So this might be a question that they ask. So go ahead and try and figure out how you would solve this problem. And unpause the video when you're ready. Alright, so the key point to remember is that a tangent satisfies two things. It has the same slope as the function, and it has the same point as the function. So it passes the same point and it has the same slope. So that means we can get two different things to help us solve for c. So if we were to try and find the same slope, so we got same slope, that means we need to figure out what's the slope of the line. So the slope of the line, that's a 2. And the slope of the curve, that is going to be the derivative of f. So that is f prime of x, which when we take the derivative using the chain rule, the power rule and stuff, we find that this is going to be c divided by 2 square root x minus 4. So this is one system that we can have. The other one is that it needs to have the same point as the slope. Or not the same point as the slope, the same point as the function. So that means that we know that our x value at least satisfies 2x plus 12, so our line is equal to the function c square root x 4 plus 2. Now from this, our goal is to try and solve for c. So if we were to solve this one first, what we can do is we can try and solve for c and isolate it. So we got 2 is equal to c over 2 square root x minus 4. Let's see, multiply both sides by 2 gives us a 4 equals c over the square root of x minus 4. So then this tells us that c is equal to 4 times the square root of x minus 4. So what we have done is we have gotten one variable in terms of the other. So we can take this and we can plug that into this equation here. And when we do that, we will get 2x plus 12 is equal to 4 square root x minus 4 times the square root of x minus 4, whoops, don't need a parenthesis there, plus 2. So we get a 2x plus 12 equals 4 times x minus 4 plus 2. So we got 2x plus 12 equals 4x minus 16 plus 2. So subtract the 2x from both sides. And then let's see, this is a minus 14, so add 14 to both sides. And we get 26 equals 2x. So we found that our x coordinate is 13. But that's not what we're looking for. We're looking for what value of c it's going to be. So now what we're going to do is we will take this value of x and we plug that back into here. So that means we know that c is equal to 4 times the square root of 13 minus 4. So that's a 4 times the square root of 9, which is 4 times 3, which is 12. So that means that c equals 12 is the value that it would pass through. Or not the value it would pass through, but that would be the value of c that makes the line y equals 2x plus 12 tangent to the curve c times the square root of x minus 4 plus 2. And then you could check that and plug in our x value to see what other points it passes through, but this is going to be how we would do it. So let's do one last problem before we finish up this review. And let's, in honor of the year it is, let's do the limit as x goes to -1 of x to the 2021 plus 1 all over x plus 1. Okay, evaluate what this limit is. Well, hopefully you recognize that this is equal to f prime at -1, where f of x is equal to x to the 21. So if we take what our derivative is, f prime of x, that's going to be a 2021 x to the 2020. So that, when we evaluate it at -1, f prime of -1, that's 2021 times -1 to the 2020. -1 to the 2020, that is just 1, so this is equal to 2021. Alright, I hope that this review is helpful. Feel free to check out my other reviews and my other videos that I've made. So I have videos on a lot of these different topics. Feel free to check them out. I wish you all the best of luck on your test, and have a great rest of your day.